All right, so we're going to start talking about percents. We're going to talk about this for a couple of videos, so we're just going to kind of do a little bit of intro right now. All right, so first I want you to brainstorm, maybe even pause the video and think of words with either the prefix or the suffix cent. Okay, so pause and maybe think of a few of those. So I can think of centimeter, centipede, century, sorry, that's not an I, centennial, that means once every 100 years, even cents, like dollars and cents. Okay, I'm sure you can think of others. Okay, but notice in all cases, right, centimeter is 100th of a meter. It takes 100 centimeters to get to a meter. Centipedes are supposed to have 100 legs. I don't think they really do. Centuries have 100 years, right? This means once every 100-year celebration or something. And then, of course, there's 100 cents and a dollar. So quite literally, the prefix or suffix cent means 100. So you may have never really thought about this before, but per cent literally means per 100. Okay, so an example of that, of course, 12% means 12 out of 100, right? Or 12 hundredths, okay, if we're talking about it in decimal form, or even 0.12. Okay, so notice the reason you change to change from a percentage to a decimal, that you move the decimal place twice, is because you're dividing by 100. You're moving the place value 2 places. All right, so I want you to get out your the packet under the worksheets to print that looks like this. Okay, it's a multi-page document. Okay. So I want to just kind of look at some of these and see if we can kind of figure these out. Notice this is called a 100 grid because literally it is 100 blocks in a grid. Okay, so notice it's really easy to discover why this is 7%, right? It's 7 out of 100. Okay, what about part B? What would that be? Okay, so part B is 20 out of 100. So, of course, this is literally 20%. Okay, what about C? C, there's 10 shaded out of 100, so that would be 10%. Notice that when I have it as a square, it's really quick and easy to see, hey, that's 100 squares. Okay, it's a little harder to see when you see it like this. This is actually 25 by 4, which is still 100 little squares in the grid, but it's harder to see that way, obviously. Okay, and if you were to count those, you would get 30 out of 100, or 30%. All right, so I want you to pause the video, okay, and I want you to try to estimate what you think all of these measurements are, okay. Part of what we teach when we teach elementary math, part of it involves them being able to estimate, okay. In fact, there's state testing questions where they don't want them to tell the actual answer, they want them simply to estimate, okay. So I want you to pause the video and see if you can determine kind of how much percent of that 100 grid, notice it's not marked, each of those pictures represent. Okay, so hopefully you did that. Let's just see how close your estimations are. Okay, again, estimation's a skill we want our students to be able to do. Notice this one's really easy, right? This is 25%. It's pretty clear it's taking up like 1/4 of it, right? Okay, this one may be a little harder. By the way, I can kind of cheat here because I have like an overlay that gives me the 100 grid, right? Which makes it a heck of a lot easier to try to figure out what these are, okay? But this exercise was really more about estimation than it was anything else. So this should have been 40%. So when I give you the answers, just make sure that your estimates were kind of close, okay? The real answer here is about 28%. Notice here's where it starts to get a little harder, right? Especially when they're kind of curved edges. How do you figure that out? Okay, well, this one comes out to be about 20%. So, you know, if you're within, I would say 5%, then you're okay. It'd be better if you were a little closer. This jack-o'-lantern looking face is 28%. Okay, this one, if you guessed around 50%, that's pretty good, but it is actually 53% if you lay the grid over it. This goalpost looking thing, 38%. This one, I would reason to myself, hey, that doesn't even look like a quarter, so I know it's going to be less than that. It's actually 14%. And then this Psychology ink blob looking thing is going to be 27 to 28%. Okay. So just a little exercise to see how close you are at estimating. No big deal if you're a little off. Just, you know, maybe try to compare it to things you already know. Okay, so let's look at this together. All right, so I want you to do this much like we did the fraction exercises, okay? So let's talk about this. So let's look at part A. A set of chips is on Timmy's desk, but an index card is covering some of them. 75% of the set is shown. How many chips are in the set? Okay, so in other words, 75% is shown. That means 25% is not shown. So I can go ahead and label that. Okay, so what I actually need to do is split this 75% into equal size pieces, i.e. in 3 groups, right? So notice if you were to split it like this, then each of these 5 chips would represent 25%. So just like with fractions, if we want to have equal size pieces or groups, and we do, then that means that this group would also have to have 5 in it. Okay. So one way to kind of talk about that, let's break this one down a little bit more. So we have 75%, which is 75 out of 100, right? But then if we are going to reduce this and show our work, we could divide both of these by 25. And that reduces to something that is proportional to 3/4. Okay? And remember, way back in the fraction unit, remember the top number tells you what you want or have. So this tells you that you have 3 groups. And then the bottom number tells you the parts to a whole. Okay, so there are 4 groups in a whole. Okay, and that's really why we drew 3 groups there. Okay, split them up into 3 groups. So let's use that kind of mentality with part B. Okay, so we have 125%, right? It's still out of 100. Okay, so the first thing you would do is reduce by dividing both by 25. And notice we'll get 5/4. Okay, so I'm not going to write out the whole thing, right? But this means I have this many, right? And this is the groups to a whole. So I have 125%, but I only need 100% in the end. Okay, so how are you going to split these up? So you need to split up these triangle shapes into 5 groups. So even though they'll be laid out a little differently, notice this works, right? And if I was going to label these, and I would want you to, you would label each of these 25%, 25%, 25%, all the way across. So I have 125%, okay, but I only need how many groups? 4 groups. So rather than try to squeeze this in, I'm just going to write this out. So 100% will be 4 groups of 3 triangles. Okay, so if I were drawing that out on homework or something, I could literally draw 4 little subgroups of 3 triangles. All right, so let's see if you could do maybe the 151 on your own. Okay, so maybe pause the video and see what you get there. All right, so notice this one is asking you to draw 150. Okay, so that's not what we have, right? That's what we want. We have 100%, so let's think of it like 100 out of 100, right? But we want 150%, so we need to make sure we could split it up into equal groups. So it would be nice if we split this up into 50% groups, right? And then in the end, how many groups will we need to get to 150%? We'll need one more than we have, right? So 150% will be 3 groups of 3 chevron-looking things, okay, or Star Trek lapel shapes. Just let the nerd come out there. All right, so what about this one? 66 2/3%. This is an odd one, but it's actually, believe it or not, a really common percentage that we need to know. So 66 2/3, I'm going to put a star by this because you're going to need to remember this. 66 2/3 means 2/3. Okay, because it's 66 2/3 out of 100. It is exactly 2 out of 3. So remember, this is what I have, right? And this is the groups to a whole. So I have this, okay? By the way, a little strange, but each of these would be 33 1/3%. 33 1/3 means 1/3. 33 1/3% means 1/3. So 100% would be how many groups of these? In other words, here's 2 groups, but I'm going to need one more, right? So 100% will be 3 groups of 4 trees. I'm not going to draw as detailed of that. My artistic skills are not so good, so I just draw the basic one. All right, let's look at E. How many stars are in set K? They said this was set K. Well, that's the easiest thing we've done so far, right? There's 4 stars. Okay, so how would I draw 200%? Well, I just need to remember that 200% is 100% plus another 100%. Okay, in other words, it's 2 full sets. Okay, so if I wanted to show 200%, I'm going to draw stars this way because it's easier. Okay, notice this would be 100%, but I would need a whole other full set. Okay, so the total answer, of course, would be 8 stars. And so what do you think 300% would be? Okay, so 300% would be 3 sets of 4, right? So 3 full sets. So I won't draw the full picture out, but the total would be 12 stars, right? But if I asked you to do this on your homework, you would need to draw it all the way out for this one too. Okay, so essentially we can almost always just compare percentages to the way that we discussed fractions in the first unit of the course. Okay, so the top number is how many groups I have / how many do I want, and then the bottom number is always how many groups make a whole. Okay, so last but not least, I want to look at some applications of percentages. And again, next week we're going to delve more into percents, but for now I just want to look at some word problems that use percents. Trying to find my copy of the worksheet here. All right, so we'll be looking at the worksheet that's labeled Exploring Percents in just a minute. But before we do that, I do want to talk about how we can handle just general percentage problems without having to really rack our brain so much. Okay, there's two types of percentage word problems. One involves decreases. Okay, so an example of that might be like sales. Something's on sale for so much percent off. Price reduction, which that's pretty much the same as sales. Maybe in older circles, depreciation, right, etc. Anything where the price is being reduced. All right, so for any kind of reduction problem, I'm going to show you kind of a shortcut that I want you to try. Okay, rather than doing it the way that some people do it, which is they find how much the sale is off the price and then they subtract it. Okay, we can actually do it in one step instead. So this is how you do that. You just subtract the discount percent from 100%. In other words, you focus on what you're paying, not what you're saving. And then you just simply multiply that times the original amount. So let's practice that. So let's say I'm shopping and I want to buy a $40 shirt. That's what it says on the price tag, but it's on sale for 30% off. So we're not going to worry about tax or anything. I'm just asking you what the sale price is so you can decide if you want to buy the shirt or not. So rather than finding 30% of 40 and then subtracting it from 40 like you might be tempted to do, I want you to think about it in another way. So I want you to think about what you are paying for the shirt. If you're saving 30%, you are paying how much percent? You're paying 70% of 40. Okay. And so the sales price more directly than you having to multiply and then subtract, you can just do 40 times 0.70, okay? And of course, the 0.70 is just the decimal form of 100% minus 30%. And then if we pay attention to decimal places, we'll just get $28 here. Okay, you could just do 4 times 7, right, and then move the decimal place once. Okay, you can do that one in your head if you do it that way. Notice in this case, rather than multiplying by the decimal and then subtracting, we're subtracting at first, and it's easier to subtract things from 100% than it is to try to subtract like dollar and cents amounts. Okay, sometimes those aren't even whole numbers, right? So that can be a little bit of a challenge. All right, so that's how we handle any sort of decreases. So I want you to take the same approach for increases. Okay, so let's talk about some things that are increases. Sales tax, right? You're adding to the purchase price. Interest, like if you have a checking account or savings account that earns interest. Appreciation, like a lot of times real estate grows in value, right? A lot more technical, but technically this would work too. Exponential growth, like anything that's going up. So I'm just going to say etc. All right, so again, a lot of times people figure this in 2 steps. Okay, they find the sales tax, for instance, however much the tax would be, and then they add that to the price. Okay, but I want you to try a strategy that's a little different. So for any increase problem, I want you to try to add the increase percentage to 100. Notice it's the same strategy, right? Just instead of subtracting from 100% like we did for reductions, we're adding to 100%. And then just like we did for the decrease problem, we're going to multiply that times the original amount. Okay, so let's try one like that. And again, I want you to maybe resist the urge to do it the way that you have done it and try it this new way. So let's say that I spent $30 at Walmart on 2 movies, but that's before tax. So I think the sales tax rate for most places around here is the same, but it can be different in different places. So it's usually 8 point something. So we're just going to say it's 8.25. That's a pretty common sales tax rate. I want you to tell me what my final price is. And we might want a calculator for this one, because I happen to give you like a decimal percentage. So again, we're going to try to do this in one step, not two. Okay, so our think step is, rather than focusing on, adding at the end, okay, we're going to focus on what you are paying. And we're going to add that 8.25% to 100. So you are paying 108.25% of the $30 price tag. Okay, so that might be a little foreign to you, but this just means we're doing 100%, right, plus an extra 8.25%. Okay, so don't let that throw you off that it's over 100. It's over 100 because it's an increase. This is the original, right, and then we have an extra being added. So if I want to know the total price, I can just do 30 times 1.0825. Okay, notice I moved the decimal place twice, right? So that's what we do with percentages. So if you do that with probably a calculator's help, right, we could get that the price is $32.48. So keeping that in mind, I want you to pull out this worksheet, exploring percents. Okay, and I want us to look at some of those, and I want you to use the strategies that I've just mentioned. In other words, focus on whether it's an increase or a decrease, and then either add the percentage to 100 or take it away from 100. Okay, and then I want to go over some of these problems. So go ahead and pause the video and take maybe 15 minutes or so. I actually want you to read over this worksheet and see if you can figure out what all the prices are, and then I'm going to do kind of some selected ones from the worksheet. All right, so I don't really want to talk about 1, 2, 3, maybe even in 4. They're all pretty straightforward. I do want to talk about maybe number 5. Okay, so this is number 5, and we can do 6 together on the Exploring Percents worksheet. Okay, so let's read over this. So Joshua has a job, okay, the economy is in bad shape, so all the employees take a 20% cut in pay. However, the next year, the economy improved and they gave them a 20% raise, okay, and he's confused because he's not back to where he was before, okay. So let's talk about why that is. Let's work through that together. So let's talk about what we know. We know his original salary before they started changing things at all was $30,000. Okay, so let's take this in order. So now let's talk about the pay cut. Okay, so after the pay cut, remember we're going to use our formula that I said before. So we're going to say, okay, I know I'm making $30,000 or he's making $30,000, but he took a 20% pay cut. So I'm going to focus on what he's still making, which is 80%. Okay, so before I tell you what that answer is, this is our kind of shift in thought. We're worried about what he makes, not what he lost, right? He makes 100% minus 20% for a total of 80% of what he was making before. So if you multiply 3 times 8, you get 24, right? So it's 24,000. Okay, then the next year things are better, right? So they're going to increase it. Okay, but notice they're going to increase it from where it is right now, right, which is 24,000. So this is an increase, right? So instead of subtracting it from 100%, we add it to 100%. So I'm going to multiply it by 1.20. Again, I'm not worried about what he's making more than what he was making before. I'm just worried about overall what he's making. He makes 100% plus an additional 20% from where he was. Okay, in other words, if your boss comes in and tells you you're going to make 100% of the salary you made last year, that means you're staying steady. Okay, so anything over 100% means you're getting a raise. Okay, and if you multiply that back out, you only get 28,800. Okay, so notice a couple of things. Notice 28,800 is not what he was originally making, right? That's why he's confused. So the question is, why didn't the pay cut followed by the pay increase, since it was the same percentage, why didn't it come out to be the same? Okay, and it's because basically we're taking percentages of smaller amounts here, right? So I'm going to say this. The reason it doesn't work is because the pay raise is being figured on a smaller amount. In other words, the 24,000 rather than his original 30. Okay, so that's why. That's one of the principles of percentages, right? It depends on what you're taking the percentage of as far as what the value is. Okay. All right, so let's talk about number 6. What raise would undo the pay cut, right? He would need a $6,000 raise to get him back, right? So let's look at number 7, okay, and see if we can figure out a formula, okay? So this is basically what he needs, right? So let's talk about that 6,000 and maybe make a ratio out of it. He needs 6,000, right, out of the 24,000 that he was making after the pay cut. So this reduces to 1/4. So how could I figure out what this would be over 100? Okay, that's a pretty easy one, right? What percentage is 1/4? So he needs 25% more. 20% more doesn't get him back to 30,000, right? It only takes him to 28,800, okay? All right, so I think that's all we'll do today. The back part of this, again, you don't have to turn it in, but it would be a good idea for you to look at it, okay, just to kind of practice this new method we're talking about. But you'll have opportunity to practice that on your homework. Okay, so next week we're going to continue to talk about percentages, but we're going to look at them kind of with some applications different from the sales and sales tax examples we just did.